Shop the Plato's Closet Black Friday event in North Charleston and West Ashley and let the deals begin. You know Plato's Closet always has a huge selection of trendy recycled styles at amazing prices, but Black Friday deals are different. They're better. We've been holding back some of our best inventory, and you won't want to miss our Black Friday event. Save on gently used styles from Patagonia, Lululemon, Lilly Pulitzer, and hundreds of popular brands. Plato's Closet is ready to let the Black Friday deals begin. Plato's Closet, located in West Ashley on Sam Rittenberg Boulevard and North Charleston on Rivers Avenue.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 24, Episode 19. Coming up on SpaceTime. Touchdown as NASA's Mars Perseverance rover lands on the Red Planet. A new model to predict galactic stellar production. And Russia starts off its 2021 rocket launch season with a bang over Australia. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
After a 7-month, 472 million kilometre journey, NASA's Mars 2020 Perseverance rover has successfully touched down on the surface of the Red Planet. Packed with groundbreaking technology, the largest, most advanced rover NASA have ever sent to another world touched down right on target in a dry river delta inside the 45-kilometre wide Jezero crater. The crater sits on the western edge of the Ascidius Planitia, a giant impact basin just north of the Martian equator. Scientists have determined that 3.5 billion years ago, the crater had its own river delta and was filled with water. The site was chosen because it's covered in sediment that had been carried down from further upstream, thereby providing a rich hunting ground in the search for life beyond Earth. Key to the successful landing was Perseverance's final approach, culminating with what mission managers like to call the 7 minutes of terror during EDL, entry, descent and landing.
Nothing can be taken for granted when you get to Mars. There's a lot of things we just don't know.
Space always has a way of throwing us curveballs and surprising us.
I mean, until we get the data that says we're on the ground safely, I'm going to be worried that we're not going to make it.
Entry, descent, and landing is often referred to as the 7 minutes of terror because it takes about 7 minutes to get from the top of the atmosphere of Mars to the ground safely.
The spacecraft has to do all of this by itself.
There are many things that have to go right to get Perseverance onto the ground safely.
There's a lot counting on this. This is the first leg of our sample return relay race. There's a lot of work on the line.
Starting about 10 minutes before atmospheric entry, we get rid of really the spacecraft part of the rover that's been supporting us.
We come screaming in to the Martian atmosphere at 12 to 13,000 miles per hour.
And the heat shield is what dissipates all that initial energy through friction.
The vehicle will continue actually flying itself through the atmosphere. It's sort of like a transforming vehicle that went from spacecraft, and now it's kind of like an aircraft actively guiding itself.
When we're going slow enough, we deploy a parachute.
The biggest supersonic parachute we've ever sent to another planet. It's critical for slowing down the vehicle.
Perseverance's entry, descent, and landing borrows heavily from that of Curiosity.
But fundamentally, Perseverance is a different rover. She's bigger, she has different instruments.
We've added a lot of smarts on the inside to make it more capable so that it can deal with the landing site that we've given it.
The science team identified Jezero Crater as basically an ancient lake bed and one of the most promising places to look for evidence of ancient microbial life and to collect samples for future return to Earth. The problem is it's a much more hazardous place to land.
You look at Jezero, all you see is danger. How do we go to a site that we never thought was safe enough to go to before? So the heat shield, which has protected us all the way through entry, is no longer necessary. We need to get that off so that we can actually see the ground. And we can see the ground in a couple different ways.
Perseverance will be the first mission to use terrain relative navigation. So while it's descending on the parachute, it will actually be taking images of the surface of Mars and determining where to go based on what it sees. This is finally like landing with your eyes open. Having this new technology really allows Perseverance to land in much more challenging terrain than Curiosity or any previous Mars mission could. Amongst the rocks and the craters and the cliffs, these things are hazardous to the rover, but these are the things that are interesting to the scientists.
Once Perseverance has figured out where she is, we jettison the back shell and parachute and light up our rockets. Those rockets help us steer to a safe landing spot that's nearby.
That descent stage takes us all the way down to about 20 meters off the ground.
That's when we start the sky crane maneuver. And once the rover has hit the ground, the descent stage will cut loose from the rover and fly away to a safe distance. Surviving that 7 minutes is really just the beginning for Perseverance. Its job, right, being the first leg of sample return, to go look for those signs of past life on Mars. All that can't start until we get Perseverance safely to the ground. And then that's when the real mission begins.
And in that report from NASA TV, we heard from Mars 2020 Guidance, Navigation and Control Operations lead Swati Mahan, Mars 2020 Flight Director of Cruise Operations Matt Smith, Mars 2020 Entry, Descent and Landing lead Al Chen, Entry, Descent and Landing Communications System Engineer Chloe Sakia, and Entry, Descent and Landing Operations lead Arisa Stelly. But all those thousands of hours of preparation, simulations and rehearsals, all the testing and retesting, and all the checking, double-checking and triple-checking of code for the 1000th time can never fully prepare you for the real thing, as the $2.5 billion spacecraft transitions from its cruise phase into its entry, descent and landing phase, and things get real. And the whole thing's made worse because of the 11-minute 22-second delay in signal time brought about because of the distance between Mars and the Earth, meaning the entire EDL sequence has to be automated, controlled by the spacecraft's own onboard computers.
We're about a minute and a half from cruise stage separation, about 11 minutes, 20 seconds from entry interface. Telecom is confirming that the spacecraft has switched to broadcasting tones. These tones are received directly from Perseverance, but have very limited information content. We won't receive real-time information until about 9-10 minutes from now, once the Mars Reconnaissance Orbiter starts relaying information from Perseverance. Standing by for cruise stage separation, about 10.5 minutes from entry interface. We're continuing to receive tones from Perseverance. We have indication that cruise stage separation has been confirmed by the spacecraft. In about 1 minute, Perseverance's landing software will wake up and begin the final preparations for entry. The first action it will do is to fire warm-up pulses with its entry thrusters. These pulses ensure that the spacecraft gets the thrust that it wants during entry interface.
That's confirmation that we got shadowed by the cruise stage as it passed through our beam to the Earth.
Telecom indicated actually that we could see a signal that the cruise stage went between the Perseverance entry capsule and Earth. So we saw a little blip, the data stream indicating the cruise stage separation. We have confirmation that the vehicle has started warming up those entry thrusters. Warm-up pulses have begun. At this point, the spacecraft is trying to stop its spin from the cruise 2 revolutions per minute down to 0, and then will turn to its desired orientation from entry. It will separate the 2 balance masses that has kept it balanced during all of cruise. This will allow the entry capsule to have lift when it enters the atmosphere. We have confirmation that the spacecraft has turned to the desired entry attitude.
DTE from Radio Science from Green Bank reports carrier lock. They see the carrier on the downlink.
Flight level 1.
We are continuing to wait for entry interface. We have confirmation from Greenback that they are receiving direct-to-Earth telemetry via that path. The spacecraft Perseverance is currently transmitting heartbeat tones. These tones indicate that Perseverance is operating normally and has nothing significant to report. This is as expected. We're still receiving heartbeat tones. We expect to continue receiving heartbeat tones until about 5 minutes after entry. At that time, Perseverance will be no longer in view of our antennas here on Earth. About 90 seconds prior to entry, the Mars Reconnaissance Orbiter should begin receiving telemetry from Perseverance and streaming it to Earth in near real time. There are a few expected short outages such as when we have a plasma blackout or when we enter the peak heating phase. Aside from these outages caused by the plasma blackout, antenna switching, or high dynamic events, spacecraft events, we should have telemetry until about 90 seconds after landing. A plasma blackout is when the signal from Perseverance isn't strong enough to make it through the superheated, super fast air flowing around the spacecraft all the way down to Earth. Once the temperature drops below that peak heating, we do reacquire the signal from Perseverance. Perseverance continues to report heartbeat tones, indicating everything is nominal.
MRO reports the electroradio is powered on, ready to receive signals from the lander.
Mars Reconnaissance Orbiter has reported that it's ready to receive the signals from Perseverance. It should be in a few minutes here. We're just
Flight Local 1
from entry interface. A second spacecraft, MAVEN, should begin picking up telemetry from Perseverance and will continue to record that telemetry until several minutes post-landing. We won't get that data for several hours after landing as it's being recorded and then will be forwarded to Earth later. We are continuing to receive heartbeat tones, indicating that everything is nominal. We're just under 2 minutes from entry interface. As it gets closer to Mars, Perseverance is actually being pulled in by gravity and accelerating. By the time Perseverance reaches entry interface point, she should be going just under 5.4 kilometers per second. We're at about 90 seconds from entry interface and standing by for Mars Reconnaissance Orbiter to pick up the telemetry.
MROs are in receive mode.
We have confirmation that the Mars Reconnaissance Orbiter is now relaying data from Perseverance. We're about 30 seconds from entry interface. Perseverance is going about 5.2 kilometers per second and is about 190 kilometers altitude above the surface of Mars.
Confirm your jet data flow.
About seconds from entry interface, 5.3 kilometers per second and an altitude of about 150 kilometers from the surface of Mars. We have confirmation of entry interface. Perseverance is currently going 5.3 kilometers per second at an altitude of about 120 kilometers from the surface of Mars. The spacecraft is now waiting until it begins feeling the atmosphere of Mars to slow it down. Once there is enough atmosphere, it will start controlling its path to the landing target. Navigation is also confirming that we can see a little bit of that slowdown of the atmosphere on the Perseverance entry capsule. Our current velocity is about 5.36 kilometers per second and an altitude of about 67 kilometers from the surface.
We are probably seeing MRO plasma blackout at this point. MRO has lost log.
Perseverance. We have indications that Perseverance is now performing bank reversals in the atmosphere. These are the steps in order to control its distance to the landing target. Perseverance has just passed through the point of maximum deceleration and has indicated that it felt approximately 10 Earth Gs of deceleration.
MRO has lock again.
We saw a small outage of the UHF telemetry from Mars Reconnaissance Orbiter during that peak heating phase, likely caused by the plasma blackout. Perseverance is still continuing to perform bank reversals in the atmosphere to control its distance to the landing target. Perseverance is going about 1 kilometers per second at an altitude of about 16 kilometers from the surface of Mars. We have entered heading alignment, which means Perseverance is no longer trying to control the distance to Mars, to the target on Mars, but instead is flying straight to the target. Our current velocity is about 550 meters per second at an altitude of about 15 kilometers from the surface.
MRO is reporting good telemetry log.
We are coming upon the straighten up. We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Yes.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Yes.
Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface. Perseverance now has radar lock on the ground. Current velocity is about 100 meters per second. 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers. We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation. We have timing of the landing engines. Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
TRN Safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. Standing by for cruise stage separation. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver.
We've lost direct-to-Earth tones.
As expected.
Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO.
UHF is good.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life. At this point, the descent stage has flown away to a safe distance. Perseverance is continuing to transmit direct through Mars Reconnaissance Orbiter to Earth.
MRO reports they're still getting telemetry from the lander.
All right, all stations. Touchdown confirmed. We're going to wait for the images. Flight, we have seen the completion of EDL 3000. Copy activity. That is as expected.
MRO is still seeing a strong signal from the lander.
Flight, this is OL3. I have the target point on the map.
Mars 2020 mission was launched on July the 30th, 2020, aboard an Atlas 541 rocket from the Cape Canaveral Space Force Station in Florida. The Perseverance rover mission marks an important first step in efforts to collect Mars samples for return to Earth. About the size of a car, the 1,026-kilogram six-wheeled mobile laboratory will undergo several weeks of testing before it begins its 2-year primary science investigation of Jezero Crater. Perseverance, or Percy as mission managers at JPL like to call it, is equipped with 7 science instruments, a robotic arm that's some 2 meters long, as well as 19 cameras and 2 microphones. It's only the 5th rover to successfully complete the journey to Mars, all of them from NASA. It all started with the Pathfinder mission back in 1997 and its Sojourner rover, which was about the size of a microwave oven. It was followed by the twin Mars exploration rovers Spirit and Opportunity in 2003. They were each around the size of a golf cart. And then in 2012, we saw Perseverance's older sibling Curiosity, which is still active and busily exploring Gale Crater. Perseverance will investigate the rock and sediment of Jezero's ancient lakebed and river delta to characterize the region's geology, minerals and past climate. But its primary mission is astrobiology, the search for signs of ancient microbial life on the surface of Mars. Perseverance is just the first step in bringing back rocks and regolith from the red planet as part of a future Mars sample return mission now being developed by NASA and the European Space Agency. This will allow scientists on Earth to study samples collected by Perseverance to search for definitive signs of life, past or present, using instruments which today are too large and complex to send to the red planet. Verifying that microscopic life exists or once existed on Mars carries an enormous burden of proof. Director of NASA's Planetary Science Division, Laurie Glaze, says while scientists will learn a lot from the advanced instruments aboard the rover, it may very well require the far more complex laboratories back on Earth to truly determine whether these samples carry evidence that Mars once harboured life. Even today, debate continues among scientists as to whether the 1970s-era Viking lander's so-called Mars Life Soup test picked up biological or chemical reactions. Nor can scientists settle the question of whether the chain structures discovered in the Martian meteorite AH84001 found in Antarctica were biological or mineral. Built by NASA's Jet Propulsion Laboratory in Pasadena, California, Perseverance includes 7 key science instruments. There's the Mastcam-Z, a pair of zoomable science cameras on Perseverance's remote sensing mast or head that creates high-resolution 3-dimensional color panoramas of the Martian landscape. Also located on the mast, the SuperCam uses a pulsed laser to study the chemistry of rocks and sediment, and it has its own microphone to help scientists better understand the property of rocks. After all, if you're a geologist, there's nothing like tapping them. Located on the turret at the end of the rover's robotic arm is the Planetary Instrument for X-ray Lithochemistry, or PIXL, and the Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals Sherlock instruments, which will work together to collect data on Mars's geology close up. PIXL will use an X-ray beam and suite of sensors to delve into a rock's elemental chemistry. Sherlock's ultraviolet laser and spectrometer, along with its wide-angle topographic sensor for operations and engineering, or Watson imager, will study rock surfaces, mapping out the presence of certain minerals and organic molecules, which are the carbon-based building blocks of life on Earth. The rover's chassis is also home to 3 science instruments. There's RIMFAX, the radar imager for Mars Subsurface Experiment. It's the first ground-penetrating radar on the surface of Mars, and will be used to determine how different layers of the Martian surface formed over time. And that data could help pave the way for future sensors to hunt for subsurface water ice deposits. And with an eye on future red planet explorations, there's the Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE. It's a technology demonstrator designed to manufacture oxygen out of the thin carbon dioxide-rich Martian air. Materials used for different types of spacesuits and space helmet visors are glued on a test panel on the rover chassis to see how they survive in the real Martian environment. Meanwhile, the rover's Mars Environment Dynamics Analyzer, or MEDA instrument, which has sensors on the mast and chassis, will provide key information about present-day Mars weather, climate and dust. Currently attached to the belly of Perseverance is a tiny Martian helicopter called Ingenuity. It too is a technology demonstrator, one that will attempt the historic first ever powered controlled flight on another world.
Sometimes you have to do something just to show that you can do it. When the Wright brothers flew for the first time, they flew an experimental aircraft. And in the same way, the Mars helicopter is designed to show that we can fly powered helicopter flight in the Martian atmosphere.
From day one, this was the unwavering dream of our team, to get our helicopter launched to Mars so that we can get that opportunity to do the very first rotorcraft flight test in the actual environment of Mars. It's extremely difficult to fly at Mars because the atmosphere is so thin. Compared to Earth, at Mars it's less than 1%. So the first and foremost challenge is to make a vehicle that's light enough to be lifted. And then the second is to generate lift. The rotor system has just been very fast. 2,000, 2,200, 2,400, 2,600. We're spinning between 2,000 and 3,000 revolutions per minute, and it takes a lot of energy. So it's that balance of a very light system, yet having enough energy that's needed to spin the rotor so fast to lift, and on top of it, having to design in the autonomy.
It has to be fully autonomous from the time it takes off to the time it lands. What we do on the ground is we plan the flights, and so we determine from here where we want the helicopter to go.
Our experiment window is 30 Martian days. So we have planned up to 5 flights of incremental difficulty.
Very first flight, the main thing is we want to get the legs off the ground, and so we will basically go up about 3 meters, and we'll hover there, and then we'll come down again, and that will be the first, really major milestone.
Most of our flights will be at the 3 to 5 meter height. We will be going horizontally again at a few meters per second, probably go out, 50, 70 meters and come back. In successive flights, we'll probably push that further, try to go further. So our priority will be to get back engineering telemetry and not so much images, but I'm sure we'll return a few, because they'll always look cool.
At this point, we've tested all we can on Earth. We have mathematical models that shows how it'll fly at Mars, and we've tested it in the simulated environment that we can create on Earth. It really is time now to do the real flight test at Mars.
Nothing is a given, but we have done everything we can in terms of a test program here on Earth. The vehicle's performing extremely well so far. It's been doing exactly the right thing, even right now when it's bolted onto the Perseverance rover. So there's a very good chance that we'll pull it off, yes. But it's still high risk, and none of us forget that you could have a glitch that, could mean end of mission, yes.
It's going to be exciting, reacting to any surprises we have. We can't wait. What's really most important is Everything we're learning here is for the future rotorcraft systems that we want to introduce into space exploration.
And in the report from NASA TV, we heard from JPL project manager Mimi Ung, JPL Mars helicopter chief pilot Harvard Grip, and JPL Mars helicopter chief engineer Bob Ballaram. Over the next month or two, project engineers and scientists will put Perseverance through its paces, testing every instrument, subsystem and subroutine, and recalibrating everything to make sure it works the way it should. Only then will they deploy the helicopter onto the Martian surface for the flight test phase. If successful, Ingenuity could add a new aerial dimension to exploration of the Red Planet, in which such helicopters serve as, well, sort of scouts, I guess, showing the best way over certain terrain, or even making deliveries for future astronauts away from their home base. Once Ingenuity's test flights are complete, the rover's search for evidence of ancient microbial life will begin in earnest. That raises an important question. If they find it, what then? See, Earth and Mars have been swapping rocks for billions of years as comets and asteroids slam into the ground of both worlds, throwing ejected debris high into space following a major impact. That debris and any surviving microbial hitchhikers aboard then float around in space until they're caught up in the gravitational well of either the Earth or Mars, and eventually fall down onto the surface, hitchhikers included. Now, what all that means is that any discovery of life on Mars similar to what's found on Earth would support the panspermia hypothesis and raise some tantalizing questions about whether life began on Mars or on Earth, and whether or not we're the invaders of the other planet or whether we're really Martians. It's a fascinating thought, but it also means that life may only ever have been created once. Even more intriguing would be the discovery of life that doesn't follow the Earth Life rulebook, because that would mean that life could form spontaneously anywhere under the right conditions. And that implies a universe full of life. Both are fascinating possibilities. Of course, Perseverance isn't the only Earth mission to have arrived at Mars this month. Earth's latest invasion of the Red Planet also includes China's Tianwen-1 spacecraft, which went into orbit around Mars last week. The 5-ton probe will spend the next 2 months studying the Red Planet from orbit before deploying a small lander. The mission will select one of 2 potential landing sites in the Utopia Planitia region. Once on the ground, the lander will deploy its own small rover designed to explore the surrounding area for up to 90 days. Beijing says its mission is designed to study the Martian geology and minerals, as well as searching for evidence of past and present water on the Red Planet, looking at the planet's internal structure, its atmosphere and local space environment. Also just arrived in Mars orbit is the United Arab Emirates Space Agency's HOPE mission, which was launched on Japanese H-2A rocket from the Tanegashima spaceport south of Tokyo. HOPE will monitor the Red Planet from a wide elliptical orbit ranging from 22,000 to 44,000 kilometres. This high supersynchronous orbit, as it's called, will provide the 1,350 kilogram spacecraft with a global view of Mars, letting scientists study the changing seasons across the face of Mars, looking at its atmosphere and climate. And it doesn't end there. There was to be a 4th mission to arrive at Mars this month. The joint European and Russian space agency ExoMars mission, a follow-on from the earlier ExoMars Trace Gas Orbiter mission that arrived 2 years ago. But a combination of last-minute engineering issues and COVID-19 have delayed that launch until 2022. This is SpaceTime. Still to come, a new model to predict galactic stellar production. And Russia starts its 2021 rocket launch season off with a big bang over Australia. All that and much more still to come on SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
A new study suggests that massive galaxies with extra-large extended disks produce stars over a longer period of time than their smaller, more compact counterparts. The findings, based on new models of galactic evolution reported in the Astrophysical Journal, imply that the sheer size of a galaxy influences when it stops making new stars. The study's lead author, Dr. Andrew Gupta from the University of New South Wales, says there was a period in the evolution of the universe known as cosmic noon, about 10 billion years ago, when star formation in massive galaxies was at its peak. After that, gas in most of these galaxies grew hot, in part because of their central supermassive black holes, and they stopped forming stars. Gupta and colleagues found they could predict the end of star formation based on the size of a galaxy's disk, the flat circular region surrounding its centre comprising stars, hydrogen, gas and dust. They found that in galaxies that were really stretched out, things didn't heat up as much, and the black holes didn't exert as much influence, so stellar production continued over a longer period. Gupta says it shows that where stars in the disk are widely distributed, resulting in a more puffy structure, the gas stays cooler and continues to coalesce under gravity, forming new stars. But in more compact galaxies, the molecular gas and dust clouds heat up significantly and so are no longer cool enough to collapse to form new stars. And so star formation finishes by just after cosmic noon. The authors developed their new model using cosmological galaxy formation simulations integrated with deep space observations from MOSEL, the Multi-Object Spectroscopic Emission Line Survey. The simulations required millions of hours of supercomputer time, and the MOSEL survey needed data from both the 10-metre Keck telescope in Hawaii and the Very Large Telescope in Chile, as well as NASA's Hubble Space Telescope. The findings provide the first direct relationships between disk size and star making. In fact, it allows astronomers to look at pretty well any galaxy and accurately predict when it will stop making stars. Our own galaxy, the Milky Way, for example, is a massive galaxy that's still making stars at a rate of roughly about 1 solar mass every Earth year. It's because it's something of a cosmic late starter. The authors say that when cosmic noon arrived 10 billion years ago, the Milky Way was still relatively small, containing just a tenth the star mass it has today. In fact, it didn't obtain its current massive status until much, much later. As a result, the gas and dust it contains hasn't warmed up enough yet to quench the star-making process. It is not, however, a so-called extended puffy galaxy, so it will quench sooner rather than later. Gupta says cosmic noon was a very long time ago, and by now the universe has reached cosmic evening. It's not nighttime yet, but star-making has definitely slowed down.
So stars are made, so not everything in our universe, it starts from gas. From the beginning, from the Big Bang, we only had gas. But that gas, it collapsed under gravity and slowly it cooled down. And when the gravity was so strong that even the gas could not hold on to itself, it collapsed. And that's how the first stars formed. When the gas could not hold on to itself and it collapsed under gravity. And that's how the stars form. And all the stars that you see in our Milky Way, they formed at some point in the past 13 billion years or through this collapse of gas.
And one of the important aspects of this is the temperature of the gas. If gas is moving very fast, it has different properties for stellar production compared to gas that's moving very slowly and has time to form molecular hydrogen.
Yes, absolutely. For a gas to actually collapse under gravity, it has to be really, really cold. Because gravity, it cannot collect, it's a long distance force, but it's not very strong. If the gas is moving really, really fast, all the atoms are whizzing past each other, they would not be able to come together into a ball and sort of allows the gravity to take over. If there's too much kinetic energy, too much temperature in that gas, it won't be able to collapse and form the new star. So temperature is one of the key factors. And how fast the gas can cool down is also one of the key factors that determines how efficient the new star-making process is going to be.
And so, keeping these principles in mind, you guys have developed a model based on observations that indicate the size. It's not just the size, it's the density, the puffiness, as you put it, of a galaxy is important. Tell me about that.
Yeah, so actually what we find is that we find a direct link between the size and the star-making process in the galaxy. What we find is that the compact galaxy, they blow out or they turn off their star formation really fast. Whereas the galaxies which have really puffy disks, they continue to form new stars for a long time. So in this work, what we are focusing on cosmic noon, which happened about 10 billion years ago. And at that time, the galaxies were crazily forming new stars. There were a lot of new stars that were continuously forming. And at that time, a lot of gas was getting pushed into the centers of the galaxy. And what the centers of the galaxies have? They have this supermassive black hole. And all that funneling of gas, it leads to really rapid growth of the supermassive black hole. What all this activity does is, it exerts a lot of pressure. It raises the temperature of the gas, as we had talked about earlier, that temperature is really important for the new star making. All this energy that is injected by the black hole and the new star making into the gas, it kind of stops, and it stops the gas from collapsing under gravity and making new stars. But what happens in puffy galaxies or galaxies which have really extended distribution, everything is really slow. They are making stars, but the star making is really extended. And the black holes, they are not so strong. So the star making process, that can continue for a long, long time. Someone used an analogy to explain this, and I quite like it. You can think of it like forest fire. So a small fire in a really, really dense forest, it can burn down the entire forest. But if you light that same fire in a garden, which only has a few trees here and there, then that small patch of that garden might probably die, but most of the garden will probably survive. So what are extended puffy galaxies? They are more like a garden than a really, really dense forest. And they survive for a long, long time.
And how does the Milky Way fit in all this?
So the Milky Way, it's a massive galaxy, but at cosmic noon, it wasn't a massive galaxy. It was about 1/10 of its current size. And it only attained its massive status after it underwent a series of mergers over the period of time. And since our Milky Way is not as extended as the extended galaxies that I'm looking at, so it's going to quench after some time. Sooner rather than later, I would say.
Now, you used an important word there, quenching. Quenching can occur in all different sorts of manners. A quasar being produced, an active galactic nuclei, can cause quenching. At the same time, when you have two galaxies merging into each other, as has been the case with the Milky Way, that can trigger star formation as well.
Mm-hmm.
So you've got all these other factors you've got to consider that have to pile on top of the model that you guys have created.
Yes, absolutely. But that's why it has been so, and we still don't really understand how exactly the quenching is basically shutting down of star formation. And we still don't know how actually the star formation shuts down. And that's why this prediction, our work is quite significant, because it shows that by just looking at the size, we can make a prediction that how fast this quenching will happen. And the thing is, the size is not, there's no direct link between the size, but the thing is, size is telling us about the underlying star formation density and how big the supermassive black hole is. And that black hole is actually doing the quenching. It's not the size that's actually doing or prolonging or slowing down the quenching. But the size is telling us about the underlying black hole mass and how fast that black hole is secreting and what that black hole is doing. So this is really exciting, because by just looking at the size, the measuring black hole mass, as I talked about earlier, directly measuring black hole mass and star formation, it's really, really hard, especially when the galaxies are so far away from us. The galaxies, what I'm looking at, they are about 10 to 12 billion years away from us. So it's really difficult to directly estimate how big the black hole is or how fast they are forming stars. But we can observe their size. We have telescopes that can see sizes pretty well. So this gives us a really powerful tool to predict how efficient the star formation quenching is going to be and when it is going to shut down.
Is there always a direct correlation? Because I guess what you're talking about really is density more than size. Is there always a direct correlation between density and size? Galactically speaking.
Sure.
I guess the question I'm asking is, do galaxies of a certain size all have the same density, or does density change with size? Or is it a case that a galaxy will always have X amount of density near the black hole at the center, as opposed to in the halo where we know things aren't very dense?
There is a direct correlation between size and the density. But the density here we are talking about is the density of gas. And because a galaxy is not just gas, it has stars, it has black hole, and each of those things, they have their own density profile. But what is essential for the star-making process is gas. That gas has to be dense enough that gravity can take over and cause it to form new stars.
And we see that with the spiral arms of galaxies, which is where most of the stellar manufacturing goes on.
Yeah, absolutely. And the thing about spiral arms is, if you look at the where the gas is most dense, then you see that gas is most dense just near to those spiral arms, not exactly on those spiral arms, because spiral arms are the stellar nurseries where the new star-making process is actually happening. So these new stars, what they have done is they have consumed the gas that was there. So the rest of the gas is sort of parallel to those spiral arms. That gas has been consumed by the stars along the spiral arms.
All this has real profound implications for the evolution of not just the galaxy, of the universe as a whole. We're in the stelliferous epoch at the moment. That must be coming to an end soon. Well, cosmically speaking, I guess.
Yeah. Yes and no. So as I was talking about, cosmic noon is about 10 billion years ago, and that's when the universe was really active. That's like the peak of the star formation activity in our universe. And what you can say that right now we are almost in the evening. Milky Way is still forming stars, but it's not making a lot of stars. It's only making one one sun per year. So that's not a lot for a Milky Way type galaxy. So you can say that we are almost in the cosmic evenings in some sense. We are not really quiet. Everything is not just quiet like in the nighttime yet, but things have definitely slowed down.
I guess there are a couple of wild cards in there, dark matter and dark energy.
Yeah, those two. Yes, especially dark matter. We still don't know how dark matter really assembles, especially when you're looking at galaxies which are so young, 10 and 12 billion years ago. Most of the galaxies didn't have these beautiful spiral arms. Their dark matter profile didn't particularly look like what it looks like right now. So these are absolutely wild cards. And we are trying to understand what they look like, how they assemble, how the two different dark matter blobs, they sort of come together, form a galaxy and become part of a galaxy, etc. So yes, these two are a bit of a wild card that are still requires a lot of research.
And dark energy wasn't near as important back then as it is now either.
Yeah. Yes. To be honest, I don't know if I can say anything about it. We don't know if we can say anything about how significant dark energy contribution was for the galaxy evolution back then.
I guess that depends also on the force of dark energy too, whether we're heading for a big freeze or a big rip.
Yeah, probably.
Let's talk to Anshu Gupta from the University of New South Wales and Astro 3D, the AIC Centre of Excellence in all-sky astrophysics in 3 dimensions. And this is Space Time. I'm Stuart Gary. Still to come, Russia starts its 2021 rocket launch season with a bang over Australia. And later in the Science Report, Australia's COVID-19 national vaccination rollout finally gets underway. All that and lots more still to come on Space Time. Russia started its 2021 rocket launch season off with a big bang for Australia. Russia's first rocket launch for the new year saw a Lotos spy satellite fly into orbit from the Plesetsk Cosmodrome 800 kilometres north of Moscow. The 6,000-kilogram Lotos S1 spacecraft was launched aboard a Soyuz 21B rocket and will eventually be positioned into a 900-kilometre high orbit. The mission caught the attention of Australian residents across central Victoria as the spent upper stage of the Soyuz launch vehicle lit up the night skies after it was jettisoned and burnt up in the atmosphere during re-entry. The spectacular debris trail, which lasted about 20 seconds, was seen by people as far away as Bendigo, Daylesford, Rochester, Kyneton, Echuca and Cashmore, streaking across the sky before exploding in a flash. Locals first speculated it might have been a meteor, but its low angle of descent and its low speed, just 6 kilometres per second, are all telltale signs of it being space junk. The Russian Lotos S1 is a Signet intelligence gathering satellite. It's designed to detect, locate, eavesdrop and characterise foreign military radio communications. This is Space Time. And time now to take a brief look at some of the other stories making news in science this week with a science report. Australia's COVID-19 national vaccination rollout is finally underway. The rollout is months behind those of most other nations. That's because of stricter drug testing procedures by the Therapeutic Goods Administration and the extremely low rate of COVID-19 infections in Australia, which is mostly COVID-free. The vaccine is being given out in 5 prioritised needs-based phases. The first, known as Phase 1A, which is now underway, is restricted to the most vulnerable people, the aged and those needing disability care. It's also being given out to their care providers, as well as frontline healthcare staff, border security and quarantine personnel. The second group, known as Phase 1B, will include other healthcare workers, people aged over 70, Aboriginal and Torres Strait Islander people aged over 55, younger adults with underlying medical conditions or disability, and critical and high-risk workers, including defence personnel, police, fire and emergency services, and meat processors. Once these are all taken care of, the rest of the community will be vaccinated, again in 2 groups. The first, known as Phase 2A, will include adults aged between 50 and 69, all Aboriginal and Torres Strait Islander adults aged under 55, and other critical and high-risk workers. That'll be followed by the Phase 2B rollout, which will include the rest of the adult population. Now, if recommended by doctors, a third Phase 3 will be initiated to vaccinate kids. Vaccinations are voluntary, and you should be seeing your family doctor first. Meanwhile, the latest opinion polls commissioned by the Health Department show that 64% of Australians will definitely get the COVID vaccine, while 27% are still unsure if they want it or not, and 9% will definitely refuse the jab. The survey also found that 48%, that's nearly half of all Australians, will get the vaccine as soon as it's made available to them, and 71% will want to be vaccinated by October. The survey found the top 3 reasons for getting the vaccine were to protect oneself, to keep other people safe, and to protect the elderly and most vulnerable. The top 3 reasons for refusing the jab were concerns over unknown long-term side effects, the vaccines being developed too quickly, and concerns about allergic reactions. Some 2.5 million people have now died from COVID-19, and another 111 million people have been infected with the virus since it first emerged from Wuhan, China. Australians have been blocked from accessing news through their Facebook feeds. The move by the $500 billion social media giant is the latest dramatic escalation of Facebook's refusal to pay for the news it uses. It comes as Google has reached agreements in Australia to pay to share news content with News Corp, 7 West Media and the 9 Network. But Facebook's actions aren't just affecting the news they're stealing. In a more sinister move, it also shut down pages carrying important community welfare information from health authorities on COVID-19 and the COVID-19 vaccination information, from fire and rescue and emergency services during what is now the height of the Australian bushfire season, from the Australian Weather Bureau as the country goes through the height of the cyclone season, as well as police, advice on domestic violence, multiple charity pages, even Children's Hospital and Kids Cancer Service sites. The move's also increasing pressure on politicians to legislate to treat social media giants as publishers, with all the responsibilities and legal obligations that entails, rather than simply being service providers. Boeing has completed its first flight test of its new F-15EX fighter jet. Based around the famous F-15 Eagle, this latest variant of the air superiority fighter is equipped with new, more advanced battle management systems, new sensors and weapon systems, and new electronic warfare technology. It includes fly-by-wire controls, an all-new digital cockpit, and the world's fastest mission computer. Current plans call for the US Air Force to obtain at least 144 of the aircraft. The Mach 2.5 capable F-15 was regarded as the world's best fighter jet and the world's leading air superiority fighter. It was at least until the arrival of the F-22 Raptor. But with only 399 Raptors in service with the US Air Force, the F-15 will remain a top-line air superiority fighter for some time. Scientists say the 2020-2021 La Niña event has now passed its peak, but impacts on temperatures, rainfall and storm patterns are continuing. A report by the World Meteorological Organization finds that despite the general cooling influence of La Niña, land temperatures are expected to remain above normal for most parts of the planet until at least April. Scientists say the above normal for La Niña temperatures are due to the warming impact of man-made climate change. Well, if you've ever watched Finding Bigfoot, you'll know that despite plenty of eyewitness reports, lots of howls, rock throwing, banging branches, and even the occasional footprint, the show's 4 intrepid investigators never actually find a Bigfoot. Of course, North America isn't alone when it comes to reported sightings of giant hominids. Even the tiny city-state of Singapore has its own Sasquatch candidate, as Tim Mendham from Australian Skeptics explains.
There's actually monkey men type thing, Bigfoot characters almost everywhere in the world. We actually did a study once of Bigfoot in various places. You can hardly find a country that doesn't have one or two. There's a lot in the US, all over the place, places you'd think there'd be no chance of having a Bigfoot. But in Singapore, which is not exactly a big area, it's an island. A lot of it is built up. In the middle of it is a bit of a national park. It's called Bukit Timah, which is Timah Park.
It's about the size of a backyard, isn't it?
Well, it is. Yeah, the whole thing is about 1.6 square kilometres. So it's about 1 by a bit less than 2 kilometres. That's the park, the whole park. Now, in there is supposed to be living a Bigfoot-type character, and supposedly has been since the Second World War, when Japanese soldiers were supposed to have spotted it, and people are spotting it still. So therefore, it's been around for 70, 80 years. Presumably it's the same one, because no one's ever really, I don't think anyone's spotted a family. Then again, it's not very big, and this park has bike trails through it, it has hiking trails through it. In fact, during peak season, they have to limit the number of people going through it because it's too crowded. But nonetheless, people can still claim to see the monkey man, as they called it, and it's not a particularly big area. It is wooded, but there's so many paths through it and bikes and all sorts of things going through. This poor monkey man must be having a terrible time. Can't get a moment's sleep. But yes, I think it's actually one of those sightings that is about as likely as, well, nothing. But there are photos, and one particular story that was published fairly recently has some rather unconvincing photos. A rough shape in a park somewhere amongst the trees, and if you highlight the rough shape and do lots of imagining and do lots of touching up, etc., you can see what looks like a very tall monkey man, which would be hard to hide in a small area, 1.6 square kilometres.
They're called squatch blobs, and they're very common when you're looking for Sasquatch in the United States. It's the closest you ever get to evidence.
And in Singapore, this one would be squashed, definitely, because it's such a tiny area. Poor thing.
Okay, so we have the Yeti, the abominable snowman in abominable, I'll get that right one day. The abominable, forget it. We have the Yeti in the Himalaya.
And the abdominal snowman?
The abdominal snowman. That's obviously, someone saw bones from Gigantopithecus. That's where that probably originated from.
Well, that's been suggested since,
I mean, that melted footprints in the snow. And then you've got, in the United States, Sasquatch, Bigfoot. You've got a lot of bears that, I've seen them, they walk on their hind legs. Not all the time, but they do occasionally, especially when they want to intimidate another bear. We're assuming that's what that is. Where does the Yowie fit into it, you think?
Good question. Actually, someone's trying to figure out exactly how old the Yowie legend is. Now, the impression is that it's an Aboriginal legend dating back hundreds and hundreds of years, etc., and that it was something picked up by the first settlers. Others are saying it's a fairly new claim, and in fact, the word Yowie might actually come from Yahoo, which is the hoon sort of word. You're a Yahoo, which also comes from Gulliver's Travels. So that might be a lot more recent word for it, a name for it, I mean, like 20th century, and that it might be a name for something that doesn't exist. The trouble is, again, it's the old story of people supposedly see it in the Blue Mountains west of Sydney and various sort of wooded areas around eastern Australia. You don't tend to get a lot of it in the west, but people tend to see only one. Although, there's one fellow who's claimed he's been attacked and almost kidnapped by Yowies up near Brisbane, and whether he sees families or not, but you have to have a big community to keep these things breeding. The old story. It's like the big cats, the panthers that have sort of disappeared into the wilds, left over by American troops or something like that.
And the thylacine in Tasmania, the Tasmanian tiger, we keep hoping to find more of them, that they've become extinct because of hunting and that sort of thing. But even if there was one or two, that wouldn't be enough to maintain a population.
No, you have a very inbred population as well. I don't know how long Yowies are supposed to live. I don't know how long big feet are supposed to live either. They're the same as human lifespans, or if it's a lot less, whatever. But you'd need more than one. In fact, you'd need a whole bunch of them. You'd need more, as you say, You need more than two. And if you've got two, you've got kids. And then if you only got the kids, you start to inbreed. It's a bit like Adam and Eve. But you need a big population in these areas where you just do not see them. In fact, the evidence, like this one from Singapore of Yowies in Australia, is not very good. But people say, yeah, there's a lot of evidence. But if each bit of evidence is pretty poor, like a 2 out of 10, a lot of them doesn't make a 10 out of 10. It makes a lot of 2 out of 10s. That's all you've got. So each bit of evidence you have to judge on its own merits. This photo from Singapore is pretty pathetic. And the same, unfortunately, goes for Yowies and Bigfoot and Yetis and all sorts of things as well.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.